Hey, Patrick, it's wonderful to touch base with you again. It's been a little while. We both spent a little time at one of the best AI companies out there, H2O, H2O.ai. Maybe what you could do, Patrick, is tell me to get started from an introductory perspective. What is bnh.ai? What is its mission statement, and any exciting news that you guys have had in the recent past?
Yeah, thanks for asking, and great to see you, Sanjay. So B&H is a newish law firm founded about a year and a half ago, right before COVID lockdown happened. Actually, kind of cruel timing there. But since then, we've built a client base, and we work with really some of the largest companies in the U.S. on managing AI risk. And that can be across any number of domains. Mainly, we work in algorithmic bias, but we also work in data privacy and security, and also third-party risk. I think that anyone who understands building machine learning models in large organizations knows it's rarely all done in-house. And bringing in third parties, of course, increases your risk, and in very complex ways in AI, because AI is so complex. So that's kind of what we do. And we also have been lucky enough to work with the U.S. government, and that has been, very rewarding for me. That was one reason why I left the high-paced sort of startup world, was to be able to take on some work with the U.S. government. And I can say, I can't talk about much of our work publicly, but I can say we are the first law firm to receive a research grant from NIST, and we'll be involved in their AI standard setting work. So
that's really fantastic
about that.
Yeah, that's great.
So, it's going well.
Great. Yeah, good to hear. Good to hear. I hear one of my colleagues from Immuta is also one of the founders at B&H. That's the B part, correct?
yeah, that is.
Yeah, cool. By the way, I quoted your paper from Toward Data Science on this chasm between trust and understanding. And you've been at this for a little while. Can you tell me a little bit about what got you interested in data science, and as an erstwhile president used to say, the truthiness in models, and you teach as well, so can you kind of wrap that up and give me some interesting tidbits?
I'll try. So I got interested in data science in chemistry graduate school, and I was in physical chemistry graduate school. I'm one of the many people that made the jump from physics, and we can call physical chemistry physics light. I think physicists would appreciate that, and maybe that's right. So I made the jump from sort of physics light to data science, and the way that happened is, we were doing all these cool experiments, and I just found myself drawn to analyzing the data. Like that's what I was good at. I was a danger in the lab. It's a miracle that I didn't burn down an entire building. But I was really good at analyzing the data, and really enjoyed especially visualizing high dimensional data. And just this whole thing set me up really well. And the little story I tell is, in computational chemistry, at least back in the mid 2000s, what we were doing was moving atoms and molecules around until they got to a low energy state. And really what machine learning is moving model parameters around until they get to a low error state. And so it's all the same math, and it's really just different names. So when I made the jump over to data science, I just had to learn new names for things, and that's easier than learning things from scratch, I guess. And how I got interested in the quality of models, I guess, is just the scientific method. Like a model is an experiment. I don't really know how a model cannot be an experiment. And so when you're doing experiments, you're supposed to follow the scientific method, by God. And so that's how I got interested in quality of models, because I just saw a lot of people not following the scientific method. And I think in some ways the kind of typical data science setup violates the scientific method, digging around for hypotheses. let's leave it at that. I can go on and on about this.
Okay,
So I'm gonna let you ask your next question.
Thank you. It's a great analogy to energy minima. I spent a little time in computational chemistry as well. It's either 0 or 1, atoms of Bohr being in higher states, but let's leave it at that. And it's also a great great move from designing good experiments. DOE, which is what we're all taught as scientists, is extremely important. Design an experiment.
It's lacking from data science. I rarely see people doing design of experiment in data science, and I think that's kind of sad, and I think it impedes our progress actually as a field.
So continuing that kind of thread, if I have a random data set, give me some insight on where you would start before even getting to all the data cleaning and data hygiene and security and provenance and other things. What are the first steps you would take to choose a model, and how do you decide what a good model is?
So the first step is know thy data, right? And so, I need to understand what the columns in the data set mean. I need to understand the context in which the data was collected, because that's incredibly important for understanding both like statistical bias and historical bias. I just need some basic common sense know-how about the data, right? I need some understanding of the domain from which the data was collected. This is a point I find myself making a lot, that good machine learning still requires human domain expertise. And people say, what about deep learning? My response to this is that in the late 1980s, Jan LeCun and his team had the brilliant idea of injecting domain knowledge from image manipulation into neural networks. And that is why convolutional neural networks work so well. They are tuned to their domain. And so, machine learning requires domain knowledge. And just because people forgot that domain knowledge was injected into deep learning in the late 1980s doesn't mean that it's not there. It just speaks to the kind of historical ignorance that is prevalent in data science.
Thank you. I guess both from a physical chemistry and protein chemistry perspective, AlphaFold has taken some really big jumps. Yes, it's not fully there. Yes, it's probably a good tool that helps the protein crystallographers not do years and years of work, which is painful. And well, technically it is deep learning. So, any comments? Any quick thoughts on AlphaFold?
I want to see more transparency around it. I want to see it succeed in broader sets of problems. But I am hopeful. I don't want to come across as too cynical about machine learning and AI, because the sad truth is we need it, and we need it to work. We have some serious problems in our civilization that we are going to need to rely on technology to fix, and AI and machine learning are going to be a crucial part of that technology. So I just want more robustness. I'd like to see more robustness in AlphaFold.
That's a good word.
Robustness.
That's a good word.
Proof of more robustness.
Yes, and more transparency. And so that the whole continuing that thread a little bit more, especially in the deep learning space, and especially after some interesting publications in the last 6 months. Does size matter in data? Does a larger size data set matter, or does a better curated data set with better tagging and labeling matter, or both?
Both. All things equal, I'd prefer a larger data set. I think it's been shown pretty conclusively that large data is a good regularizer. Makes your models more robust and out of sample performance. I think the key is, but all things not being equal, I would prefer higher quality. I would definitely do quality over quantity. And I think that was one thing that was just left out of the whole big data craze, was that a lot of big data was obviously low quality, and that made it much less valuable. And so I take quality over quantity any day, But it's not that small data is bad. It's just that you need to be careful with machine learning and small data because of overfitting. And I think, you know, it's weird that we just have to love big data. You know, that we can't even have these kinds of nuanced conversations. It's either like big data or small data. But obviously it's just, we have to deal with both, and both have different risks.
So let's say you have a large data set of dirty data. I would love to hear your opinion on, you know, can we inject synthetic data that is actually nicely fit, maybe post hoc, and then combine it with this real data set with lots of faults and follies. And so your take on how you, would that be a good approach to quality and verifiability?
Okay, so in the law firm's legal work, we oftentimes find ourselves dealing with highly sensitive data with pretty serious regulations around it. And in general, you know, I think it's really important for data scientists and you know, even the general public to understand that data about people, even in the US, is becoming a more regulated quantity. So you can't just do whatever you want with data anymore, generally speaking. And I do think that's a good thing. I don't think the regulations get everything right, but I do think it's a good thing. So very oftentimes we do have to rely on synthetic data. And I think we're going to find ourselves relying on synthetic data more and more because of data privacy regulations. I don't think that's a bad thing. I think synthetic data can help models be more generalizable. I think synthetic data can help in testing models. So of course there's nothing like the real thing, but I have found myself using synthetic data more and more, and I'm quite excited about the possibilities for synthetic data in the future.
Quick follow-up. Do you think there'll be specialized synthetic data sets for certain vertical industries, for example, or certain regulated areas?
Yeah, I would expect that. I would expect that. And I think we're already starting to see some software packages emerge to help generate data for specific applications. And so for me, this is a bright spot in machine learning, synthetic data. Thank you.
This is actually germane to your work as a law firm. So you've talked about data quality a couple of times now, but data provenance also matters, you know, where it comes from. Can you throw a little more light on both of those topics from your perspective?
Yeah, I think data provenance is very scary to me, actually, or let's say unknown data provenance or unknown data lineage is really scary to me because of it's mainly because of the data privacy regulations. That's the main way you can get yourself in trouble, is you could be using data that was collected illegally if you're not sure where it's from. And as states, you know, I don't want to get into a political discussion, but you know, the federal government in the US has not been able to pass a federal data privacy regulation, so it's being regulated state by state. Yep. And that makes things extremely complicated because something that's illegal in one state might not be illegal in another, and vice versa. And then of course I'll throw this, there's the obvious algorithmic bias issue, which you know, sadly goes without saying these days. I'll highlight the security issue also. Data sets can be poisoned. And as AI or machine learning systems become more and more central to, you know, different types of technology in our lives, we can expect more attacks on those systems because that's just the sad nature of reality. And we can expect that data sets will be maliciously altered to evoke certain responses from machine learning systems, and it's probably already happening.
Great point. And I think, at least from my angle where I see this, healthcare, we all know what happened last year. And the pandemic actually taught us a lot of different stories about modeling, first of all, and how little we know, and how humans don't understand exponential growth and things like that, and security as well. So continuing that thought, and the Wild West is gone. It used to be unknowingly borrow or steal, data that is. And I think that's probably going to get tighter and tighter, especially in the healthcare context, where security is probably the worst in any industry. So how then do you think we could both secure the data, and more importantly, how do you version the models that use this data set and bring both the model and the data when somebody wants to validate it? Your thoughts on that?
So this is another sort of bright spot for me, and I don't get to try these tools out as much as I like. But there's the DVC project, which is an open source project for data versioning. There's these sort of open source / kind of freemium offerings like Gigantum, which is a full environment manager for data science. And then there's Domino Data Lab, right? There are companies that are built off this idea of sort of end-to-end environment management for predictive modeling. My take here is, again, it's a bright spot for me. It's great. And it's only going to have to become more common. I think in general, people have simply underestimated the difficulty of building machine learning systems for high stakes environments, right? If you want to build a machine learning system that just shows ads on a video game, and human people have reviewed the ads and they're not too offensive and that kind of thing, and they're not racist, then go for it. Go fast and break things. Make your black box machine learning model. But when we're talking about healthcare and employment and credit and physical security and driving cars, that is where these models are going to have to more and more be a part of these completely managed environments. I just don't see any other way. Because of the reproducibility concerns, the security concerns, the data lineage concerns. So I think, taking up massive disk space with managing tiny changes to data sets is just going to become more and more common as this technology becomes more robust and more mature and is deployed in more and more high stakes scenarios, or else it's just not going to work. That's how I feel.
Yeah, reproducibility is one of the scourges in science. I was remembering part of the background. I was remembering one of the papers from about 5 or 6 years ago on the fact that less than 50% of biomedical data can be reproduced by another lab, and that's pretty sad. So, what does trust in data mean to you?
Well, reproducibility is a cornerstone. I'm not sure that's the only aspect, though, because we already talked about security. So we have to understand the lineage. We have to understand, experiments related to the data have to be reproducible. We have to understand the biases in data. And, we, as part of our work at B&H, we do study AI failures. And sadly, as I've kind of intimated at several times in this conversation, the most likely way that people go wrong with machine learning right now is algorithmic bias. So we need to understand the bias in the data set, both sort of historical and demographic biases, but also statistical biases, right? Like the data can just be repetitive and redundant and collected the wrong way. And, we already talked about this notion of design of experiment that could be done better in a lot of data science applications. So there's a lot there to trusting data. And again, I'll just tie that back into my comment of it's just harder than people think to get this right for high stakes systems, right? You don't just go grab a data set off the internet and grab a Python package off the internet, train and deploy. There's a lot more to it than that.
So I'll come full circle to your paper and to our data science in November 2019 on this causality chasm between trust and understanding. And you eloquently quoted a couple of the driving factors on both ends of the fence. Where are we going in terms of causal inferences and bringing some more domain knowledge as they used to do in the pair programming thing, for example? Any thoughts?
I'm going that direction, and I do think that industry will go in that direction. So So I'm a big fan of constrained models, using domain constraints to inform the architecture of your machine learning model. Just like we talked about with convolutional neural networks. I would claim that is one reason why convolutional neural networks work so well. They took domain knowledge from the domain in which they're supposed to be functioning and incorporated it directly into the architecture of the models. So like when I'm building models in financial services or employment, these high stakes use cases, I want to know, I use a lot of monotonicity constraints, right? Like as, I don't really, we should get, all right, I want to circle back to one thing about truth in data. You know, I want to know that as someone's length of credit file goes up, that the model is always going to make them more likely to get the credit product, right? Because that makes sense. And more than it making sense, it's verifiable. You know, it takes some of the mystery out of how this black box works, and it makes it more testable. And then when you get concerned about bias, that's where the interaction constraints that you find in packages like XGBoost can be really, really helpful, because, you know, two variables on their own might not be that indicative of demographic class, but all of a sudden when the machine learning model combines them, and especially for kind of a pocket of people in the data set, all of a sudden it's a direct proxy for protected class, and you have a lot more bias in your model outcomes. So, you know, I like to prevent things, say, from like, you know, cell phone type and, you know, something about geographic location. You know, you wouldn't want those mixing if you were concerned about demographic bias in your models, which we all should be. So, you know, long-winded way of saying, whether we have full causal models yet or not, I don't think we do yet. I think that we're still, you know, maybe 5, 10, maybe more years away from that, sadly. Doesn't mean that you can't take causal steps in the tools that we have today. And so I'm a huge fan of taking causal steps in the tools that we have today. And I just think it makes your models better. And whether it makes them better on your static test data set, I don't really care about anymore. So I'm looking for real world performance.
Thank you. That's a very mature approach. I think we're just probably in the shallow part of the learning process. It'll take a few more years, as they say.
Yeah.
So that brings me to my final question. I think you and I both remember. By the way, I learned the whole thing about global and local variables and Shapley from you. Thank you. So I think you and I both remember the paper in 2016 by Scully et al. From Google on technical debt in machine learning systems. I think the largest part was the serving infrastructure, but I would actually add a security infrastructure nowadays to that as well. Other areas mentioned in the paper were data collection, configuration of both the model and the data verification, process management tools, etc. Even before getting to all the fancy things in feature extraction and the actual machine learning model. So what is your opinion from a future-looking perspective? That paper was published in 2016. 5 years from now, it'll be 10 years old. You know, where does the debt lie today, in your opinion, and where are we going?
Great paper. And honestly, like, you know, many BNH clients will see this in a footnote in some of the memos that they get. It's held up really well, but I don't think we've hit bottom yet when it comes to generating machine learning tech debt. Because I think what I'm starting to realize is, yes, all the technical debt that was mentioned in that paper, yes, a lot of it still exists, and most companies aren't mature enough yet to even be able to handle the technical debt that was explained in that paper 5 years ago. But now we're starting to understand, like, algorithmic bias is a way that you can go wrong if you're not careful in the beginning. Security is a way that you can go wrong if you're not careful in the beginning. Data privacy is a way you can go wrong if you're not careful in the beginning. Third-party risk is a way you can go wrong if you're not careful in the beginning. So I think, unfortunately, for people who want to be serious about machine learning and high-stakes use cases, we're still sort of digging to the bottom of the technical debt pit, and it, you know, AI adoption is just going to be slower than it's hyped up to be. There's just no ifs, ands, or buts around that.
thank you for that reality, and thank you for the mature conversation. And this was wonderful, Patrick. We should do it a little more often here. It's great to hear it's great to hear your thoughts, and I look forward to talking with you again soon.
Yeah, sounds great.